Hey there, welcome back. So, let's do what we did last time. Let's start with a quick repetition. So, we talked about terms and definitions last time, and I've talked about this byte thing a few times already, but let's just be absolutely sure that we know what a byte is. It's a number between 255 and it can be written in 3 different number formats. And we have this thing called a constant, where we write a friendly name and we just say that name means an actual number. That number can never change once we assemble our code. So, then we have this thing called a variable. Now, a variable is just a memory address. In this case, it says my health and then a memory address. So, a variable is a very useful thing, and we are going to come back to that a little later in this episode. But just make sure that you know these things. If you need to, you can repeat a few of these things before you continue this video. But let's assume that you know what this is, and let's just continue. So, like I said, a variable. We need to be absolutely sure what a variable is before we continue. So, yeah, we can write them in these different number systems, and we have these labels here. If we want to write them directly in the code. Now, we already seen that we can do it in NESmaker in a much easier way. But the important part here is that we know that we have this label, and that's actually just a RAM address. It needs to be a RAM address if we want to write to that address or to change what's in there. So that's variables. Today, we're going to talk about something called tables. Tables is very similar to variables, but there's a lot more to it. So we're going to look at that in just a second. But before we do that, let's just look at this. Here I've made a list of names. Now I've called this list names. And in this list I have all these different names, 8 names, and I've numbered them from 0 to 7. This is basically what a table is in assembly language, but obviously this is not assembly language, but the concept is the same. So how would I do that in assembly language? Well, here we go. This is the table called my table. And the label, everything is written exactly the same as we would do it if we were making a variable. So my table here, that's just this RAM address 20, and it has this value 10. So if I cut off the lines below here, this would just be a variable. But I decided, no, I need a table right now. I need a table with 1, 2, 3, 4, 5, 6, 7, 8 entries. I need a table with 8 entries right now. Now, this is important. Either I need to remember that or write it down. Because if I'm going, especially if I'm writing this directly in the code, if I'm doing it in NESmaker, it's a little easier. But I need to be aware of how long my table is. Let's not go into that right now. But here's my table. Basically, it's just one memory address after another. But I only have a label for the first address. So how do we access these other ones? Because using variables is very easy. If this was a variable, I could just say LDA my table, and I would get whatever value was in there. But here I just have a label on the first entry here. I don't have labels for the other ones. How does that work? Let's continue on. First, let's look at this. Just briefly mention that we can write, we can set up our tables a few different ways. It doesn't matter if you create a new line after writing the label. It doesn't matter if you put an indentation like this, or if you just write it directly below like this. Also, we can write our tables like this. Write a label and then a new line, and write db and then a number, comma, and then a new number, comma, and then a new number. Write it like that. And we can even do the same thing again. Write db, number, comma, number, comma. So there are different ways to set these up. Again, it doesn't really matter. If you're going to have multiple values on the same line, then you need to separate them with commas like this. Now, if you want to do it like this, where we have 16 values here, and you say, oh, I don't want this super long line. I want to separate them in, say, 8 values. Okay, so you made one line here with 8 values, and then you just start a new line, but you need to start that new line with .db, and then you just start writing values like this, separated with a comma. So the point here is that we can write them a few different ways. You can have, spaces or indentations or whatever. It doesn't really matter, as long as one value comes after the other. The only thing we need to remember is that, like I said, if you're writing them on the same line, you separate them with a comma, and you only write .db here at the beginning of the line. For all the numbers after that, you don't need to write db for every one of these. Okay, so right now this might seem a little abstract. Maybe you feel like, whoa, what's going on here? What's he talking about? Well, let's go a little further, and let's look at an example from NESmaker. Alright, so in NESmaker there's a table called object health. So again, we write them a few different ways. Here in NESmaker there's an open line between these numbers. It doesn't matter. The assembler doesn't care about this open line. So we can do these sort of things for ourselves if it makes sense to separate them like this, because maybe it makes it easier to read. So let's look at this example. Object health. This is a table in NESmaker. So what is this object health thing? Well, you remember when you set up an object, a player or a monster in NESmaker, you can give it health. 1 unit of health, 3 unit, whatever. So the way that the NESmaker interface is set up is that we have 16 game objects at the beginning. And then if we want to create more objects, those are monster objects. So that's why we have this separation here, because it makes it easier to see that the first 16 entries in this table are for the game objects. The next 64 entries are for the monster objects. So let's look at this first entry here. Here it says 3. Now, as you can see, all of these are written in hexadecimal number system. But this first one says 3. What's the first game object in NESmaker? The very top one. That's the player object. So this means that the player object has 3 health. Now, this is not where we keep track of how much health the player has right now, or any of the other objects. This is just their initial health value. So if we create a new monster here from this object 16, if we create a new one, he's going to have 1 health. If we create a new monster object here, object 17, that new object 17 is going to have 2 health when he spawns. So this is just the initial health values. Alright, so what? Well, let's look at this, because it makes it a little easier to see what I'm talking about. Here's the object health table. And as you can see, like I said, the first entry here, entry 0, that's 3. Because I've set this player object up with 3 health. So I set it up at 3 health, and when I click export and test, and NESmaker exports all this stuff and runs it through the assembler and all that stuff, then this number 3 is put into this table. And it's like that for all the other objects as well. So, right, now let's go a little further. Let's see if we can really understand how to use these tables, because it might still be a little vague perhaps. Right, so we talked a lot about variables last time, and I mentioned it briefly just a moment ago. Should we use variables or tables? Or when should we use variables and when should we use tables? Well, a lot of these types of questions are things you need to answer for yourself. Now, in the beginning, when you're just starting out learning assembly language, it might be a little difficult to decide one or the other. But let's take a look at a few examples. Here I have a list of variables. This is a list of variables, and once again I'm going to repeat myself a few times, but here we know that a variable is just a memory address. So here I have several variables, one after the other. That means that it's one memory address after the other. Each of these have a value, just like variables tend to do. So I could make a power-up system like this, sure. I could make 8 variables to keep track of power-ups, but it seems a little unnecessary, and maybe it will even be a little cumbersome when we start programming. Need to keep track of these 8 variables. Might get a little messy. So what can we do? Can we do it another way? Well, what I would do in this case, I would make a table to keep track of my power-ups. Instead of having 8 variables, I'm just going to use one table. And that table is going to have 8 entries. Now, to get a little technical for just a second, look at these memory addresses. 20, 21, 22, 23, and so on. If we go back to my variables, 20, 21, 22, 23, that's exactly the same. Which means that this table variable stuff, that's not some special thing for the CPU. The CPU doesn't care. These kinds of things are for us as programmers. Because in the end, it's all just one memory address after the other. That's what the CPU cares about. So this is to make it easier for us as programmers. So I could do this, sure, could make a bunch of variables, but to me as a programmer, it makes much more sense just to have one table called power-ups. It has 8 entries, and I'm going to keep track of my power-ups that way. So don't worry about what these numbers mean. I just put some random numbers in there. All right, so, okay. Well, how can we access the different table entries? I mean, we have a table with 8 entries, but we just have this label on the top. How do we access these other table entries? Well, you remember last time I talked about the X and Y registers, and I called them index registers. This is where that comes into play. So let's go back to my power-ups table. What if I want to access the third entry here? Entry 0, entry 1, entry 2. What if I want to access this in my code? How can I do that? Well, the way I do that is by using the X or the Y register. In this case, I'm using the X register. The way I do it is that I say load X with 2, number 2. Load X with 2. Then I say load A. So first I load X, then I load the accumulator with power-ups, comma X. So here X is an index, or we can think of it as an offset. Here it's 2. 0, 1, 2. So when I say LDA, in the name of the table, comma X, is going to use whatever values in X as an offset. And as you know, we start counting from 0. 0, 1, 2. And we can do the exact same thing with the Y register. We just load Y with the number. And instead of comma X, we say comma Y. It works exactly the same way. So let's take an even closer look at how that works. Okay, so we have this label for our table, power-ups. Now, this label is actually just like we talked about with the variables. It's just a friendly name for this memory address. Power-ups is just the memory address 20. Okay, so what? Well, the way this index or offset thing works when we write comma X like this is that actually what we do, we say take the memory address for this label plus whatever's in X. So memory address 20 plus 2. And we end up with the memory address 22, which is what we have here. Now, that might sound a little complicated, but I just wanted you to show you exactly how this works. How we end up with this offset. Because it's all about accessing the different entries in our table. How we do that. So, just remember that you need to load either the X or the Y register with a value, and that becomes the offset. Starting from 0, we have 0, 1, 2, for example. Right. And this is, of course, the value inside that entry, that position. All right. So, this was very technical, maybe a little, maybe not boring, but maybe not super cool. But let's look at this. This is a little more fun and visual. In Contra, it's a fun game, fun shoot 'em up game, and we have a lot of different weapons we can use. We have the normal gun, we have the machine gun, spread gun, fire gun, that sort of thing. So it's really cool. But how does Contra keep track of these different weapons? How is that programmed? Well, I don't work at Konami, never have worked at Konami, so I can't tell you for sure. But can we do something like that in NESmaker? Yes, of course we can. Of course we can. Now I'm going to show you an example. And this might not be the greatest example of how to do this, but the point here is that I want to show you how we can use tables for stuff like this. So the point here is to show you how we can use tables. So let's look at this example. Here I have a weapon table. I just call this table weapon table. And it has 1, 2, 3, 4, 5 entries. Now, like I said before, we have a lot of different numbers going around, and it's, like I said, it's all about numbers, but we have to give these numbers meaning. Now, in this case, I said that here in my weapon table, each of the numbers in here, it's going to represent a game object. And just to remind you, game objects in NESmaker are these things, starting from 0 at the top and going down. So that means that here in my weapon table, each of the entries here, that's going to be a projectile. So I'm going to have 5 different kinds of projectiles that I can shoot in my game. First one here is game object 1, which is here. Next one is game object 4, and so on. Now I just taken the default list from NESmaker, so that doesn't apply to this, but I'm not going to be shooting health objects, health pickups. But anyway, hope you understand the point here. This is just a table of 5 different game objects. So then I have a variable down here called active weapon. Right now it's set to 0. Now I'm going to use these two together to create some sort of system where I shoot different kinds of projectiles. So how am I going to do that? Well, let's look at this. Here's my weapon table. If I define this a little more, I can say that, okay, the first one, that's a knife. Second one, that's a spread gun. Third is a pistol, third is a pistol. Then we have a bazooka and then a grenade. These are the different weapons in my game. So again, we start counting from 0. 0, 1, 2, 3, 4. So I have these 5 entries. Now, right now, the active weapon variable is set to 4. Right now, the weapon I have right now is number 4, which is this grenade. Right, so let's continue on here. Here I have my shoot projectile input script. Now, of course, this is just a very, very small part of that input script. But let's take a look at how I use tables in here. Here I say load X with the variable active weapon. Now right now, the active weapon, there's a 4 in there. So basically I'm loading X with 4 because that's what's in this variable right now. So I'm loading X with 4, then I say LDA weapon table comma X. So I go to my weapon table and I have comma X, so I have an offset 4, alright, 0, 1, 2, 3, 4. So basically here in my shoot projectile script, now I'm shooting grenades because my active weapon is 4. But then I continue on in my game. I walk along and then I come across a power-up. This power-up. Okay, it looks cool, so I pick up that power-up. And this is a new kind of weapon. When I pick up this power-up, the pickup script in NESmaker is run. Now in that pickup script for this object, I have this piece of code. Here it says LDA 2 STA active weapon. So I'm loading the accumulator with number 2, storing that in variable active weapon. What does that mean? Well, it just means that I'm changing the active weapon from number 4 to number 2. That's what I'm doing. That's what happens when I pick up this power-up. I'm changing the active weapon to number 2. Alright, but now I want to shoot again. So when I shoot, I run the shoot projectile input script. Now this is exactly the same input script that we were running up here. Exactly the same thing. But now when I run LDX active weapon, now there's a 2 in here instead of 4. So LDX 2, LDA weapon table comma X. Again, we need to go to our weapon table and we have a 2 as an offset. So 0, 1, 2. Alright. So now I'm shooting with the pistol because my active weapon is number 2. So I hope this makes sense. The point here is to show you how we use these offsets when we're working with tables. We're loading a value into X and we use that as an offset for our table by writing comma X. So let's look at the default NESmaker shoot projectile script. Now this is from the LR platform module, default shoot projectile script in that module. Now this is not the entire script. This is the part where the actual projectile is being created. So we create a new object, but what object are we creating? Well, we're creating game object 1. There's a hashtag here which means that this is the actual number 1. In this case, it means game object 1. That means that in this game, we're just going to be shooting with game object 1. That's going to be a projectile. Unless we make some new code or modify this one, that's what we are going to shoot in this game. This can't change. When we write a hashtag like this is basically a constant. This number can't change. We've written a hashtag here. This is the actual number 1. So, for some games, this could be okay. You don't need 100 weapons in every game. So this could be okay. But what if we wanted something more like we just talked about? Being able to shoot with a lot of different kinds of weapons. Well, let's make our own custom script here. Let's make a custom NESmaker shoot projectile script. So what we do here is basically what we did just a second ago. Here we have this code to create an object. But before that, I say load X with active weapon, just like we did before. Load A with weapon table, comma X. Again, exactly the same thing. But now I need to store that result somewhere. I can't just load it into A. I need to store that result somewhere. Where do I store it? I'm just going to store it in this variable called temp in this case. So now the active weapon, I used my weapon table. I found the number for my active weapon. In this case it was 4. So I have the number 7 now from this table. So I'm loading A with 7, storing that into temp. Then I get down here when I create this new object. What object do I create? Do I create object 1, 2, 3? I just create an object based on whatever's in temp right now. I create an object based on whatever numbers in temp right now. I just fetched the number 7 from this weapon table, which means that now I'm going to create the object game object number 7. Game object 7 is going to be my projectile right now in this case, because of how I set this up. So hopefully you can see how we can combine these different things. We have this variable, we have this table, and by combining these different things and slightly modifying this shoot projectile script, we can make a more dynamic shoot script. Like I said, this is not the perfect way or the best way, but the point here was to show you how we can use tables for something like this. Okay, I hope that makes sense. So now let's look at a little something a little different. Can we read from and write to tables? Well, the answer to that is it depends. Before we can answer that question, we need to talk about something else first. Now, this might get a little bit technical, but I'm going to try to avoid to make it more complicated than it needs to be. So anyway, I'm talking about ROM and RAM. Here it says not all memory is created equal. So ROM, that stands for read-only memory. RAM stands for random access memory. Now, if you've been working with computers for a long time, you might know this already. But ROM, that's a part of memory and we can only read from. We can't put anything into ROM. We can't change values inside ROM. We can only read from there. Now RAM, on the other hand, random access memory, there we can store and we can read and we can change values in there, so we can basically do what we want in RAM. But we can't do that for ROM. ROM is an area where we can only read from. We can't store anything or change anything in there. So why am I suddenly talking about this? We were talking about tables just a second ago. Don't worry, it will all make sense. So now let's look at what happens when we insert an NES cartridge in our NES. Well, we're not going to be talking about everything that happens. This is not, like I said, this is not a course on programming an NES game from scratch. But what happens when we insert a cartridge when we're thinking about this ROM thing? Well, the thing is that I'm going to look at an example from the first NES cartridges. That was just ROM. There was no RAM in there. So let's look at this game, Popeye, one of the first early black box games. These cartridges, like I said, were just ROM. Only ROM, read-only memory. So they contained 40 kilobytes of read-only memory. 40 kilobytes of read-only memory in here. Now the way Nintendo set this up, they split this up into 32 kilobytes for game code, 8 kilobytes for graphics. 8 plus 32, that's 40 kilobytes. So what I'm trying to show you here is that when we plug the cartridge into our NES, part of this ROM space in here is mapped to the NES memory. Now, NES memory does not mean RAM. We talked about last time that the NES or the 6502 CPU can access up to 64 kilobytes of memory. But we also saw last time that for the NES, a lot of addresses in this memory space, a lot of addresses in there are for special things like changing the hardware in one way or another. There are a lot of addresses like that. But like you see here, we also map these RAM areas to the memory, which means when we do that, we can't write or change something in that part of memory right now. That's RAM. Same thing for the graphics here. So those memory areas are turned to RAM now. In fact, if you remember, the NES only has 2 kilobytes of RAM. So there's not a lot of RAM on the NES. So we're going to come back to that in just a second. And by the way, don't take a picture of this right now and study the memory addresses, because the memory setup for the NES is really complicated and it's a little messy. We have something called memory mirroring, which makes this very confusing. So we're not going to go into detail about those sort of things. So I want you to look at this picture from a conceptual point of view. So don't study the exact memory addresses here, just try to understand what's going on. We're mapping this cartridge RAM area to parts of the NES memory space. So those areas are now locked as read-only memory. So we just need to access the RAM to make variables, for example. But the reason I'm showing you this now, we were talking about tables just a moment ago. The question now is, if you sit down and program and you want to make a table, maybe you have a long table for something like power-ups or whatever. Can you put that in part of your code that's going to end up here in the RAM space? Well, yes, you can. You can make a table like that. But you can't change the values in that table. That table now becomes a read-only table, or a lookup table if you want. So if there's a reason for you to have a table with a lot of values, then you need to look up from time to time. Then there's no problem. You can put tables like that in RAM. But just remember, you can't change the values in there. Meaning, we can't make something like a table of inventory. If you have an adventure game, you want to have 10 inventory slots, for example. We can't make a table called My Inventory, and I have 10 slots in there. Well, you can make that table and you can put it in here, but it can never change. So that defeats the purpose. So if you want to make a table like that with inventory slots, then that table has to go into a RAM area where we can change the values in that table. We can put tables in here, but those entries, those values in there can't change. So I don't want to get too super technical here, but again, I think it's good that you know about these things. Because in NESmaker, you might put a table somewhere, and in another part of the code, maybe you want to change those table values, and nothing happens. Well, that might be because your table is inside a RAM area. Not a RAM, but read-only memory. So, I just wanted you to be aware of this, how this works. Okay. But you know what? I have some good news for you. NESmaker has taken care of the complicated stuff for us. So all these super complicated things, NESmaker has taken care of that for us. So we've already looked at the user variables tab. This very useful thing where you can just click add and you add a variable. You write a name, and if you want, you could give it an initial value. So add and remove variables like that. It's very useful. By the way, we're going to come back to that later, because you can't add as many variables as you want, but let's come back to that. But that's variables. What about tables? What if we want to make my inventory, that table, where we can change the entries in there? A table that's going to keep track of my inventory. Well, if you want to do that, there are several ways, but one way is to use this tab called Overflow RAM. Here we can add, just like with the variables, you can add something here. And you just write a name here. And then we say, how many bytes do you want for this? Meaning, how many entries do you want for this table? If I want to create my inventory table, then I just click add, write my inventory, and let's say I wanted 10 slots for my inventory. Okay, then I said 10 bytes. 10 bytes for my inventory table. So I can do that here in my Overflow RAM. I could also do that here in Zero Page RAM. But like I mentioned a moment ago, it's a little easier to see here. We need to keep in mind how much of the space we're using. Like I said earlier, the NES only has 2 kilobytes of RAM total. Here in the Overflow RAM, we're already using 225 bytes. There are quite a few bytes in Zero Page RAM and so on. So this is something we need to be aware of. Generally, you need to keep this number probably below 256. So you need to be very careful about how much RAM we're using, because RAM is very scarce on the NES. And these numbers fill up really fast. So that's how we can make tables in RAM. In other words, tables that we can modify or add new values to them. So I just wanted to end today by showing you an example. Now, this is a game I made last year. In fact, it's pretty much exactly 1 year ago. I made this little game called Theo's Task. By the way, it's 95% complete, and it's a free download on itch.io if you want to try it out. But the reason I'm showing you this is, if you master this table thing in assembly language, if you really understand how this works, then there's a lot of cool stuff that you can do. In this game, I have a lot of power-ups, I have a lot of different weapons, and one thing that I was really proud of when I made this is this. This is a map system. So if you press the start button to pause your game, you get this tiny little map screen here. And this shows you where you've been, the rooms you've been in, and these red areas, that's rooms that contain a diamond. There's a diamond in those rooms, and diamonds that I have not collected. This black area, that's rooms where I have not been yet, and this little face is the room that I'm in right now. So it's kind of like, almost like Symphony of the Night kind of thing, where you can see where you've been. Now, this was made with tables, and obviously to display it like this, I'm using sprites. But the way I'm keeping track of this is by using tables. I actually have several tables to keep track of these different things. Now, we're not going to be talking about that now, because it's pretty complicated. And in fact, I wanted to make a tutorial about this, but turned out I haven't figured out how to make a tutorial about that quite yet. But anyway, the point I'm trying to make here is that just by using or knowing when and how to use tables, then there's a lot of cool stuff that you can do in your game. You can add a lot of fancy advanced features that you would otherwise wouldn't be able to. So anyway, If you want to check out Theo's task, I'm going to leave the link in the description. But other than that, that's it for now, and I'll see you in the next video. Bye bye.